Welcome and thank you for joining Electric and Power Indonesia Energy Talk series. Good morning, good afternoon, selamat siang, or good evening, depending on where you are in the world. My name is Anissa and I will be your MC for today. Welcome to today's Energy Talk 13, our collaboration with Indonesia Smart Grid Initiative and Asia Pacific Urban Energy Association. With today's topic, District Cooling System at Indonesia New National Capital. Sponsored by Rugged Monitoring, this Energy Talk is part of Electric and Power Indonesia and Building System and Automation Indonesia. Assalamualaikum warahmatullahi wabarakatuh. May peace be upon you. Ladies and gentlemen, before we kick off this session for today, we would like to inform you that today's webinar is a part of Pamerindo Sustainable Events. It's our ongoing mission to embed sustainability into everything we do and help our customers and specialist markets do the same. From our operation and business practices to the knowledge and information we provide to our customers and communities, we are committed to making a positive impact. Before start today's session, we have just a few announcements for general housekeeping. Host will mute your audio and camera. Today's session will be recorded and we will share the recorded session 2 days after the webinar. Q&A session, use Q&A button to type your question and mention to which speaker your question is for. You can also submit your question in Bahasa and we will help translate your questions for you. What you can access, recorded session, presentation slide, and e-certificate 5 until 7 days after the webinar. Submit your inquiries to max@pamerindo.com. Before we jump in the opening session of this webinar, please take a look of Electric and Power Indonesia latest edition.
Audiens yang hadir tadi banyak bertanya dan punya interest yang tinggi mengenai kelistrikan untuk kepulauan. Dan memang mereka pengen tahu sebenarnya di mana batu sandungnya mengapa listrik kepulauan belum bisa berkembang secara sempurna di Indonesia.
Sini kan banyak pertemuan konsultan mechanical electrical, jadinya pertemuannya di sini sih lebih dominan, lebih ke ketemu dari sisi-sisi konsultan sama lihat dari tim-tim yang biasa berperang di proyek sih, lebih ke situ sih sebenarnya.
Usually we get to meet about 80% of local visitors and about 20% of international visitors.
Tempat meeting point yang sangat bagus karena customer-customer kami yang lama akan muncul yang kita nggak tahu dan sangat efisien daripada keliling Jakarta, temu customer satu persatu.
It's also the opportunity to discover new leads, to talk to people that we usually don't talk and to showcase our solution.
Kemudian mungkin di masa depan bisa saya gunakan sebagai alternatif dari komponen-komponen yang selama ini saya gunakan. Jadi biar komponennya nggak itu mulu kali ya.
Kita ikut di event Electric Indonesia, terutama yang diselenggarakan oleh Pamerindo, kurang lebih hampir 7 kali sejak berdirinya CIN di Indonesia tahun 2005.
Sebenarnya agak menyesal sih kenapa nggak dari tanggal 11, karena emang seru dan dapat banyak vendor baru yang mungkin nanti bakal bisa lebih kompetitif dengan vendor yang selama ini kita gunakan.
Banyak sekali informasi dan teknologi yang sangat pesat sekali yang membuat saya wow gitu kan, dan luar biasa sekali. Dan
banyak produk-produk yang lain yang kita bisa tahu 2 tahun lalu nggak muncul, sekarang muncul apa aja. Dan kita bisa lihat kompetitor, perkembangannya, produk-produk kita yang dulu Schneider nggak ada, sekarang sudah ada. Nah, ya ini buat refresh kita untuk kedepannya itu ngapain.
Keep it up and see you in 2 years.
Okay, next, related to today's webinar's topic, we have a short video regarding Indonesia new capital to give everyone an overview of how Indonesia new capital will look like. Enjoy! Okay, welcome back and let's move to our opening session for this webinar. Already joined with us this afternoon, Mr. Peter Lundberg from Asia Pacific Urban Energy Association, Bapak Edi Widiono, Founder and Supervisory Board, Indonesia Smart Grid Initiative, Ibu Puspa Dewi, Director Energy Conservation, Ministry of Energy and Mineral Resources, Republik Indonesia. We will start this day with the welcome remarks from Peter Lundberg, Executive Director, Asia Pacific Urban Energy Association. Mr. Lundberg is an energy engineer with more than 17 years of experience as team leader, project manager, technical manager, system designer, and project planner. He has wide international experience working on projects in Scandinavia, Europe, and Asia. He has extensive experience in district heating, district cooling, energy efficiency, renewable energy, demand-side management, and sustainability urban development. Currently, Mr. Lundberg is the Executive Director at the Asia Pacific Urban Energy Association in Bangkok, Thailand. He is leading the APUA Secretariat to explore, develop, and promote sustainable energy in the Asia Pacific region. Mr. Lundberg, the stage is yours.
Thank you very much for that introduction. Hello, everyone. My name is Peter Lundberg, and I'm the Executive Director of the Asia Pacific Urban Energy Association. I have a few slides I would like to use for my welcoming remarks. So bear with me here. Yes. First of all, I want to thank everyone to joining us today for this webinar on the topic district cooling system at Indonesia's new capital city. And first of all, I want to thank our co-hosts Pamarino Indonesia and the Indonesia Smart Grid Initiative for creating this event. I would like to give an introduction to the rising cooling demand in the world and also the ASEAN region. Today, cooling produces about 10% of the world's greenhouse gas emissions, and about 80% of that comes from energy consumption, but 20% of that is due to direct leakage of refrigerants use. So refrigerant use also play a vital role to address when mitigating greenhouse gas emissions. On the graph here on the right, you can see the development of the electricity consumption of air conditioning systems in residential and commercial buildings. And you can see how much it has increased between 1990 and 2017, where the biggest growth is in China, but you can also see countries like India, but regions like Southeast Asia has had a significant growth. And looking into Indonesia, the cooling demand in Indonesia can be demonstrated with cooling degree days. It's a measurement of the cooling demand. And today's cooling demand in Jakarta is about 3,800 cooling degree days. And this is equivalent to neighboring countries, including Philippines, Malaysia, Thailand, Singapore. But you can see here the AC utilization rate in Indonesia is only around 9%. If you compare that to Thailand has 30%, Singapore and Malaysia 80%. So the cooling demand in Indonesia will grow and follow both economic and population development, but also due to climate change. On the graph here, you can see on the left, you can see the number of cooling degree days in Indonesia and the ASEAN region is increasing. So that means that the cooling demand will increase due to a warmer climate. You can see in the middle graph that the GDP per capita in the ASEAN region is growing. And on the right hand, the graph to the right, you can see a steep increase of AC ownership in the ASEAN region. Cities play a vital role mitigating climate change. And also to meet the growing cooling demand. Cities occupy only 2% of the world's landmass, but they consume over 2/3 of the world's energy and account for more than 70% of the world's CO2 emissions. And we're looking into buildings. Buildings stand for 30% of the final energy consumption in the Asia Pacific. And buildings account for a large part of greenhouse gas emissions in cities. For example, in Hong Kong, that number is 60%. In Tokyo, is 30%. In New York, is 70%. And space cooling is the fastest growing use of energy in buildings. And cooling accounted for 90% of the total electricity used in buildings at the moment. I just want to end here by mentioning some developments in Thailand. The Thailand government has put effort in investing in a new national government complex in Bangkok. So basically, it's a campus where they collect different government agencies in one place in the vicinity of Bangkok city. And this complex has a district cooling network providing 42 megawatt of chilled water for about 1 million square meters. They have reduced energy consumption with more than 100,000 megawatt hours and reduced 50,000 tons of CO2 emissions. So this is a good example of a similar trend that is going on in Thailand, and I think might be very interesting for the new capital city in Indonesia. I also want to mention that this project is the winner of the Global District Energy Climate Awards as the best district energy systems in a developing country in 2021. They will also expand to build another campus, and so the trend is continuing with this kind of government complexes, and they will also have a district cooling system about 30 megawatt. Finally, I want to welcome you all to Bangkok in September. We will host the 7th Global District Energy Climate Awards. Look forward to see you there. Thank you very much for me.
Okay, thank you, Mr. Lundberg. Next, we have Bapak Edi Widiono. Bapak Edi Widiono is a founder and supervisory board of Indonesia Smart Grid Initiative. Bapak Edi, the stage is yours.
Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Good afternoon, ladies and gentlemen, and our respected colleagues in the webinar entitled District Cooling System at the New Capital City, or IKN, Nusantara, initiated by Indonesia Smart Grid Initiative, PGCI, and Asia Pacific Urban Energy Association, hosted by Pamerindo Indonesia. We are grateful for the presence and willingness of participants from all over Indonesia and other parts of the world to discuss openly with the experts in this webinar. Today's speaker, number one, is Ms. Dinda Alamsyah, the Vice President of Power Plant Asset Management of the State Electricity Company, PT PLN Persero. Secondly, Dr. Nana Haryanto, as Head of Electric Power System at Sekolah Tinggi Elektro and Informatika ITB, and Deputy Chairman of PII, Indonesian Engineer Association, also an expert staff of Task Force for the implementation of infrastructure development for the new national capital of Nusantara. The third speaker will be Mr. Rana Yusuf Nasir, the Vice Chairman of Masyarakat Konservasi and Efisiensi Energi Indonesia, Indonesian Energy Efficiency and Conservation Society. Number four, Mr. Fajar Eko Ananto, as an Upstream Operation Officer at International Finance Corporation, IFC World Bank Group. The fifth one is Mr. Mohiuddin Saih, the Technical Manager of Qatar Cool. And the moderator will be Ms. Fatom Saulina, as Director of Saka Total Energy Management. We also thank Rock Monitoring Incorporation for sponsoring today's webinar. Ladies and gentlemen, in recent years, the Indonesian government has attempted to increase the efficiency of its national energy use. Recently, Indonesia was undergoing a process of changing its capital from Jakarta to a new purpose-built site promptly named Ibu Kota Negara Baru Nusantara, or IKN. These changes may well be a long-awaited momentum in planning a more energy-efficient national capital. One can help in achieving such is to use a more efficient and greener cooling system. It was expected that the site of the new capital would have an average 26 degrees Celsius during wet season and around 36 degrees during drier ones. With climate change in hand, designing a climate-resilient, greener, and more carbon-free city should become the main concern in constructing new city, especially a new capital. Then, is it possible to be built the new capital that is expected to grow a center and a new market hotspot for energy efficiency and district cooling system? One alternative to be the energy efficient city for a large area is district cooling. District cooling is a centralized area cooling concept, where cooling is produced in a cooling chiller plant, and the chilled water produced here is supplied via underground pipes to buildings located in areas that need it. District cooling is a more sustainable, reliable, and energy-effective solution that works by aggregating cooling demand, ideally between multiple residential or commercial buildings in larger network. The district cooling system comprises a centralized cooling plant, which houses large, highly efficient industrial-grade equipment that supplies chilled water to buildings within its grid through insulated pipelines. The cooling grid can work with power taken from a variety of renewable or clean energy sources, all the while using thermal energy storage technology to store and supply highly compressed cooled air. This highly efficient system, if implemented properly, may ease or even accelerate the transition to renewables and cleaner power sources. Here, PGCI, as a non-government organization that focuses on smart grid, smart energy efficiency, and renewable energy development, tries to connect all components to synergize with each other to reach global commitment and also to reach prosperity for all. Such as renewable energy can be the main source of the electricity for new capital city, then can synergize with smart grid, smart telecommunication, and smart technology to build a good system that can fulfill function in its sustainability. District cooling can create thermal storage that can be used for renewable energy in energy efficiency. On the other hand, the collaboration of renewable energy, smart grid, and district cooling can create the price of electricity to be more affordable. The webinar District Cooling System at the new capital city Nusantara is one of the many platforms available to discuss all sorts of information regarding Indonesia's program on implementing an early development steps of district cooling at the new capital city of Indonesia for commercial, public, and household use. As such, the experts that gathered here were to discuss several concerns, starting from, number one, the urgency of increasing the efficiency of renewable energy use in Indonesia through air conditioning load management. Secondly, the electricity demand growth from the introduction of district cooling in a new capital. The third one, perceived problems, difficulties, and obstacles in utilizing a district cooling system at the new capital city. And the fourth, the electrification for district cooling system in new capital city of Indonesia. The fifth is the regulations limiting use of inefficient cooling system. And last but not least, number 6, financial management of district cooling system for Indonesia. Ladies and gentlemen, I hope this webinar can answer most of the questions that arise in our minds as part of our critical step on introducing the feasibility of district cooling system in Indonesia. Thank you and best wishes from us, from Indonesia Smart Grid Initiative PGCI. Sobat PGCI, salam Smart Grid. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you Bapak Edi Widiono. Ladies and gentlemen, please welcome Ibu Puspa Dewi, Director Energy Conservation, Ministry of Energy and Mineral Resources, to give the keynote and open the webinar.
Thank you, Ibu Anissa.
Thank you, Ibu.
Honorable Founder and Supervisor Board of Prakarsa Jaringan Cerdas Indonesia, Bapak Edi Widiono, and Bapak Peter Lambert, and on the panelists, and also all participants. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon and best wishes for all of us. First of all, we thanks for the blessing of health and prosperity for all of us. And please allow me to convey my highest appreciation to the Indonesia Smart City Initiative for organizing this event. It is a pleasure for me to speak at this fabulous agenda with topic District Cooling System at New Capital City. Ladies and gentlemen, Indonesia defined long-term carbon emission reduction objective as part of its National Determined Contribution, or NDC. In the NDC, the energy sector is playing an important role. The energy sector is targeted to reduce greenhouse gas emission by 314 to 446 million ton oil CO2 by 2030, accounting for 11% with unconditional effort and 15.5% with international support of the national emission reduction target. Emission reduction in the energy sector will be achieved through the implementation of various programs as defined in the 2019 roadmap of National Determined Contribution implementation of mitigation action. Honorable guests, while the economy is slowly recovering due to COVID-19 pandemic, as domestic and global economies gradually reopen and the Indonesian government rolls out its COVID stimulus package, socio-economic consequences are likely to be long-lasting. The global financial crisis is inevitable as the COVID-19 virus outbreak has forced many strategic sectors to their lowest level, including the energy sector. In this pandemic situation, we promote energy management program in industrial sector and building owners to reduce their operational cost of energy usage. Case studies have demonstrated the value of implementing energy management system, showing energy performance improvement of 10% and more, with most improvement in some cases 70% or more, coming from low or no cost operational enhancement. Implementation of energy management will also benefit an environmentally friendly company image and increase its product competitiveness. Government Regulation number 70 of 2009 concerning energy conservation also mandate that energy user more than 6,000 ton oil equivalent per year must implement energy management through the appointment of energy manager, preparation of energy conservation program, periodically energy audit, and implementation of its result, as well as reporting on the implementation of energy conservation to the government, to the Ministry of Energy and Mineral Resources. Currently, the government is revising Government Regulation number 70 2009 on energy conservation. Ladies and gentlemen, the implementation of energy management is essential because through energy management, energy efficiency can be carried out systemically and sustainability, which will increase the industry competitiveness. Air conditioning system in building consume 50 to 60% for the total energy consumption. Average energy saving opportunity from building sector in Indonesia is 95% for new building and 11.2% for existing building. Global data on number of buildings in a city on an area show that there are 5% considered as new buildings and 95% 5% as existing building. It is important to note that studies have shown that energy saving potential for energy building, especially in the planning stage, range between 20 to 40%. On the other hand, the potential for energy saving for existing building is generally smaller, ranging between 7% to 18%. Honorable guests, as we all know, according to the President Directive, the reallocation of the state capital or IKN from Jakarta to East Kalimantan is not merely physically transfer of government office. The main goal of building a new IKN into a smart capital city. The IKN area must adopt the smart and green concept and will become a showcase for Indonesia's major transformation in the economic, technological, and social field. One form of this transformation is to build a smart, integrated, and environmentally friendly system in the IKN area, including the implementation of the district cooling system. District cooling system can be produced from natural resources sourced from local renewable energy, which makes it an environmentally friendly choice. District cooling system is a safe and reliable method for cooling production and distribution, providing many environmental and economic benefits, such as lowering and the overall cost of electricity infrastructure, reducing energy consumption, and lowering greenhouse gas emission, reduction operating and maintenance costs, minimizing noise impact and vibration, and increase comfort and safety. District cooling system use about 20 to 35% lower electrical energy than conventional air conditioning system. As I said before, that energy saving potential for new building, especially in the planning state, range between 20 to 40%. So that the planning for the application of the district cooling system can be feasible, has a big impact on energy saving, and environmentally friendly choice of air conditioning system as a form of sustainable development in supporting the implementation of the net zero energy building concept in the IKN area. We need to act now, starting to harmonizing and strengthening of policy to support. In developed countries, the concept of net zero energy building has started to become a norm. Net zero energy building is the initial step forward of achieving net zero carbon building, which is targeted by 2050 for some countries, for both new and existing building. This contributes to the NDC pledge issues by every country that has ratified the Paris Agreement. Indonesia will also follow this step and started with due diligence study and roadmap how to get there. Government has already drafted several points to introduce high performance building on revisions of a government regulation on energy conservation, and also developing of Indonesia National Cooling Action Plan. That will be Indonesia grand roadmap on the cooling sector toward lower emission from the sector. Respectable ladies and gentlemen, challenges will always be there, but energy efficiency need to be succeed. We are looking forward to collaborating with all parties, mainly international organizations, ministries, related associations, and all stakeholders to create a roadmap and strategy to achieve the net zero emission. We sincerely hope that this event will provide new motivation, insights, ideas, and tools to support the improvement and application of energy efficiency for building sector in IKN area in the future. We greatly appreciate the Indonesia Smart City Initiative cooperation in supporting and being our partner for capacity building, advice, and many more, especially in the current situation with their support. This could be our momentum to promote natural emission building, including energy efficiency and successfully supporting emission reduction. Finally, we would like to thank all participants and all of those who participate in organizing this event. I wish you all great success in a fruitful discussion. We hope that this event can spawn meaningful effort. Let's talk and discuss. Help the government to mitigate climate change issue. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Ibu Puspa Dewi, for your keynote and to open webinar for today. Now we are going into the discussion to explore more about district cooling, especially at Indonesia new capital, IKN Nusantara. To lead this webinar, please welcome Ibu Fatom Saulina. Ibu Saulina is Program Director of Saka Total Energy Management. Thank you for your support for this session, Bu, and hope all is well. The stage is yours.
Thank you for the kind introduction, Anissa. So, good afternoon, everyone. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera buat kita semua. So, it is great to be joining this energy talk on district cooling system and its implementation in our newly planned capital city. As previously mentioned by our guest, by our keynote speaker, that district cooling is believed to be a more sustainable, reliable, and energy efficient solution. And now this session gives us the opportunity to learn and to, discuss this particular system. And we are also blessed that we have with us 5 distinguished speakers here from different perspectives. We have from the government, academia, financial institution, experts, and practitioners. And so, and of course, the attendees that's participating in this discussion. I encourage you to put down your question, during the presentation, and we will answer all those questions at the end of the session. So without further ado, we will start with our first speaker, Bapak Nanang Haryanto. Do we have Pak Nanang here?
Yes, okay.
Okay, Pak Nanang. So just briefly introduce Pak Nanang. Pak Nanang Haryanto is a doctorate engineer. He is in the task force team of expert on infrastructure development of our new national capital city. He is also head of electric power system at STIEE ITB, School of Electrical Engineering and Informatics. And he is also deputy chairman of PII. Mr. Haryanto finished his graduate program in electrical engineering, ITB, and then continued his research and education in TU Berlin. And in 2010, he earned a doctoral degree in electrical engineering from ITB. Apart from academic, he also authored some papers in journal and conferences, some 44 conferences and more. And also he has excellent qualification in field work. So Pak Nanang, the time and floor is yours.
Okay. Thank you, Ibu. Okay. Thank you very much for this opportunity to explain how the reliability of power supporting to the IKN, to the IKN. Yeah. My task from the PIE is to make how the reliability in the IKN, how to make the electricity reliable in IKN. That's my task. Okay. Okay, I will send share screen for the concept of the this reliability. Okay, I'm Ranang Haryanto. Apakah sudah kelihatan semua?
Sudah Pak, silakan.
Good. Okay. Saya Nanang Haryanto. I am a head of Power System Laboratory in Institut Teknologi Bandung. The presentation is about the security-based approach for planning and design of electricity supply in Indonesia, new capital considering power resiliency. Okay. This is system electricity power system for new capital city. This is our assume. This is the electric consumption per capita is 4,000 kilowatt hour, and number of total energy that we will put there in the is about 6,000 gigawatt hour, and then so the need of power is 1,500 megawatt with please reserve margin is about 30%. Okay, this is the supply for the capital city. You see in the blue one, this is in the capital city. Okay. If we see the power balance in Kalimantan from the year UPTL 2021-2023, we have a capacity that the reserve margin there is about, for example, in 2024, reserve margin until we have a power reserve margin 260 megawatt and reserve margin 30% in the West Kalimantan. But in the Kalsel Tang Timra, we have a high reserve margin until 700 megawatt there. What is the potential power plant that we can do there? For example, in the Kalimantan Utara, we have a PLTA say Tugu 200 megawatt, PLTA Mentarang 240 megawatt, Sembakung 250 megawatt, Kaltara 300 megawatt, Kayan 1 900 megawatt, and Kayan 2 1,200 megawatt, and Kayan 3 1,800 megawatt, and Mentarang Indo 1,175 megawatts. In the North Kalimantan and the East Kalimantan, we have PLTA Long Bangun 20 megawatt, small, pellet hydropower Tabang 240 megawatt, and hydro also Boh in 882 megawatt, and Mentarang 1 300 megawatt. How about the concept to supply this? The new capital city. So if we have the network in the Kalimantan, we have a 150 kV substation in the red one, and we have 3 systems that will supply. That's called system Barito. It's called also system Kaltara, and so system Barito Kalsel Tang Tim. And a new capital city in the circle, in the center of the circle of from the Karyangus, Paku, Bukit Baru, Embalut, Engkawang, Harapan Baru, Samboja, and Karangjoang. This is the network that will be supplied to the new capital city. How about our concept for the development of electricity in the ultimate side? We have the blue one is 500 kV in the ring, outer ring, in the medium ring, and the center of capital city. In the center of capital city, the network will go to the capital city from the 70 kV going up to the new capital city, and then supply will be supplied by 150 kV, the first circle in the around of the new capital city. And the second round is also combined between the 150 kV and 275 kV relay, but still not there. 1 and 500 kV will be supplied to the network. Okay. That is the ultimate supply from the 150 kV to the capital city. That's capital city. In the center of the network, we can feed from the Gay Samboja, Paku, Ambalut, and Petung. There's four substation will be supplied to the new capital city. If we see there is 4 supply directly. It is good for the reliability of the power system in the new capital city. We have 500 kV will be supplied. This is already stated in the ERUPTL. That means from substation Balikpapan, Kaltim 500 MVA. From Spaku Kaltim 500 MVA also. Ambalut Kaltim 500 MVA. Tanjung Selau Kaltara 500 MVA. And PLTA Kaltara 502 times 500 MVA. This will be supplied for 500 to support also the new capital city. If we see the backbone of grid Borneo in the 500 kV, that's come from the Babah in the up, in the going to Tanjung Redep, and also Kayan Hulu long apart. This 500 kV network that will be also a part of supporting of new capital city. That is 500 kV that's already planned by utility. Here is PLN. Okay. But if we see that we have some little bit of problem with some small signal analysis dynamic in the interconnection of Kalimantan, in the frequency of inter-area oscillation and local area oscillation. Okay, this is in the network, in the high voltage and extra high voltage network. But how in the network city itself, new capital city, we will support by 20 kV model using flexible operation network for new capital city with high reliability. Okay. We have 3 zona. That is R1, R2, and R3. That's R1 is the center of with the area of 2,000 hectare, and the R2 in the district of new capital city with 4,000 hectare, 40,000 hectare, and also in the area with 180,000 hectare. Yeah, we have 3 zona that should be supplied by good reliability of electricity. This is potency, the demand estimation in the ring 1. This is of 453 megawatts. Okay, the sum of the facility there. And the ring 2 is about 1,845 megawatt, the second ring, and the third ring is 800 megawatt. So if we calculate there, we need, okay, lanjut. We calculate for the substation requirement there, we need for the ring 1, if 2 substation we need install there, 150 kV, 20 kV, and in ring 2 is X substation 150 kV, 20 kV, high voltage substation, and ring 3 a 5 substation with the capacity of 80 MVA. And the total requirement, so and the total requirement is for the substation, high voltage substation is 15 substation to support new capital city. Okay. For the low voltage distribution substation, we need we have already calculated is about 200 substation distribution will be support the total area of new capital city. How the network will be developed? The network will be developed for 20 kV is based on open loop and ring system, and also loop system and mesh system. The concept is like this: to get the high reliability to supply the all of office building and office building in the new capital city. This is the operation based on the radial open loop system that was built in interchange, like the one that like this, okay, and this is using the fork modification of the open loop system. That is we use in the airport Soekarno-Hatta, the model for the operation that with high reliability also for 20 kV 20 kV network. Okay, and also for the closed loop, that's like this closed loop loop in the network of 20 kV. That is more higher reliability than the first one and the second one. And this is the grid, operation grid. This is the alternative way of the operation of the network in 20 kV. Okay. For the low voltage, we have added some UPS and some point to get more better reliability without dip. That's mean without dip. This we calculate all of the load not allowable dip and load with allowable voltage dip. We cluster and we add the UPS system there. Okay. We have some simulation, for example, like this. For example, if fault happen in the fault happen there. Fault happen there. Fault happen there, and then the breaker here and here will be off, and then but how the system will be covered? This is the really the simulation of the network for the fault and for the restoration. This is for the open radial, how the network is covered to get the good reliability in the system. We check until n-2 contingency n-2. That means 2 of the component network here, cabling network, will be off from the system. The system is still available and good and running well. Okay. Also for this is for the low voltage. First, we see that the system will be supplied from the 2 low voltage, medium voltage, low voltage main distribution panel, and we complete it with the UPS system. This is our presentation, how to get the good reliability. We have a present about the how in the big system, high voltage, extra high voltage network, and how in the 20 kV network that will be fit into the each of housing or each of office building in the new capital city. I think good. This is my thank you for this presentation.
Thank you, Pak Nanang. It's a very interesting presentation on your work there, planning and design of the IKN electrical supply. One reminder for all the attendees, you can submit your question in bahasa. Jadi pertanyaan bisa ditanyakan dalam bahasa Indonesia dan akan kita bantu untuk translationnya nanti. Okay, so we're gonna keep all the questions for Pak Nanang until the end of the session. And next we have our second speaker, Pak Fajar Eko Antono. So we have Pak Fajar here. Pak Fajar is an upstream operations officer for the International Finance Corporation, which is a group of World Bank Group. And his focus is in urban infrastructure development. And his specialty is in the upstream or pre-investment side. He has close to 19 years of professional experience, both as an engineer and also urban planner in the public sector as well as development finance institution. He graduated from Erasmus University Rotterdam, the Netherlands, and ITB, Indonesia. Pak Nanang, whenever you're ready, Pak.
Thank you, Ibu Fatok. Good afternoon, everyone, and Assalamualaikum warahmatullahi wabarakatuh. Selamat siang dan salam sejahtera. Let me share my screen. I hope you can see my presentation. So yeah, very quickly on IFC and our role in urban infrastructure development, including in this case, in this particular session, the district cooling utility. So IFC is part of the World Bank Group, the larger World Bank Group, and along with our sister organization. And what makes us unique compared to our the other organization within World Bank Group is the fact that we are mandated to boost private sector solution to tackle or to solve development problems. And therefore, in that, throughout our history, we have committed no less than 60 billion of portfolio, and including 13 billion committed last year. And our products, or what we can offer to the private sectors working in this space, is basically, first, of course, as a financier, we provide investment. So we can work through multiple kind of instrument, either loans, equity, derivative and structured finance, blended finance, syndication, trade on commodity finance. But apart from that, one of our additionality is actually to provide also upstream as well as advisory services. In this case, we position ourselves as a long-term partner for our client, not only by providing investment, but also work with them even prior to the investment itself, to prepare the project, even sometimes to the extent of creating the market. We know that especially this is very typical in emerging market, whereby the number of bankable projects are sometimes very limited. Therefore, we are working proactively on how we can create the project itself together with our client. But once we got into the investment phase, we can also work with the client to boost their performance and ensuring that the project will run smoothly. And especially in Indonesia, we've been around for 53 years, and our portfolio currently covering a range of sectors, but notably in infrastructure, and including energy, and then also financial sector, as well as in the manufacturing, agribusiness, and services. Some of our notable engagement, among others, we are the advisor for the first PPP, Central Java, appointed by PLN, and then also our joint transaction our joint engagement as a transaction advisor with JICA for Legok Naka Waste to Energy in West Java, appointed by the Ministry of Finance and the province government. Also, recently we engaged with the Ministry of SOE on asset recycling. And let me also add another dimension to this. So apart from engaging with the private sector, we are also mandated to work with the subnational government. In this case, particularly if we refer to some of the examples in other project, district cooling can also be managed by the municipalities as part of the municipal or urban utility. Therefore, I think our client can leverage our engagement with or connection relationship with the subnational government, because we work with them in many types of instrument, many types of engagement. We provide them with commercial subnational finance without sovereign guarantee, but also we can help them in case they want to work through PPP structure, either for like a district cooling utility, as well as for other kind of utility, such as water, health and education, housing, and others. Apart from that, we also provide services, of course, and this will include things such as capacity building, project preparation, project enhancement. And in that case, what we do is, with regard to the local government, we provide them in, generally we support them in addressing their infrastructure needs. Many times they are not, they are not ready, or they don't have enough capacity to plan the infrastructure development, let alone, preparing a bankable project. We can come and help them and also improve their access to commercial financing. And this is, I think, part of the policy of the government is to open the access even for the subnational government, because more and more the government, including the subnational government, they cannot rely on public financing because of the huge demand for infrastructure development. And as I mentioned earlier, with regard to public-private partnership, and one of the recent things that we do is, of course, to promote climate-friendly solution to align to global agenda. And this is some of our example of our previous engagement with regard to the municipal and environmental infrastructure sector. And we work in many regions in the world, Asia, and then Latin America, Europe, and in other regions as well. And also here, one of the example is our recent engagement with Tabrid, which is one of the largest district cooling utility provider. And we provide them with equity. Yeah. And then what we are doing in the cooling space, what we do is we support the deployment of efficient space cooling infrastructure, including district cooling, and then also supporting low carbon and energy efficient building to reduce demand for cooling, particularly using our toolkit called AGE, which is a toolkit for green building certification. Also supporting the expansion of cold chain infrastructure and services by the parties service providers, supporting startup developing new energy efficient technologies. And as of now, until recently, we have financed not district cooling, but district heating, yeah, as many as 6 projects until since 2019. And this include the 2 private district heating companies and 3 municipal utility companies in Russia and Romania. The investment were accompanied by advisory project, and this is, as I mentioned, part of our additionality. And recently, with regards to Tabrid, we also committed 25 million of equity. This is to support their investment in Asia, and hopefully that in the future we will have a solid pipeline to expand in the region. And some of the key challenges in the emerging market, particularly in the district cooling spaces in general, because of perhaps the lack of awareness with regard to the district cooling solution itself, and also it can be also related to the local engineering and design expertise. That's why in IFC we also provide technical advisory services, because we also have industry specialists or energy specialists in this case, and also the fact of the unpredictability of supply and cost of energy, as well as the policy and regulation. And with regard to product, especially in financing, we provide loans, both directly or through intermediary, and then equity, both directly or through private equity funds, and then also derivative and structured finance. But this is, for info, this is should be linked also to loan or investment. And trade and commodity finance, this is perhaps more relevant to the manufacturing sector. Syndication and also blended finance, in which we can use donor funds to crowd in private financing. And if we look at our investment cycle, we may start with pre-development. In this case, what we call as upstream seed, whereby it's kind of the R&D of IFC to do market scoping as well as assessment, or legal and regulatory review, previous studies, and also proceeding to development. We can do also upstream projects, where we do project preparation, and then finally we can do financing or mainstream investment. But in case like there is some project that is already ready to finance, some like a very well established project sponsor, of course we can move directly to mainstream investment. Yeah, and this is perhaps the ideal situation for us. And then lastly, with regard to climate finance to support the global agenda, we also provide what we call as climate-linked financing, whereby we we develop and implement solutions to better address client needs, such as corporate green loan or bonds, yeah, and also blended finance, so that our client can work to achieve their commercial objective, but in the same time can also achieve what we call as the climate KPI. And this is linked in one package, integrated into one package. And some of the eligible projects, eligible sector, including waste management, water management, drill building, renewable energy, and others. Yeah. So let me stop here. And apology, I may not be able to attend the session until the closing because of other agenda. But happy to take any question. But if not possible, happy to catch up with any one of you. Please reach out to me through the organizer. Thank you very much. Now, back to Ibu Fatom.
Thank you, Pak. It is uplifting to see how IFC is promoting energy efficiency and greener energy. And also I see very uniquely that IFC is proactively creating projects with clients. Unfortunately you cannot join us, but we will take all the questions and hopefully you can help us with answering those questions later, Pak Fajar.
Yes, definitely, Bu. Yeah, thank you very much. Yes.
Okay, so next we move on to our third speaker, Bapak Insinyur Dinda Alamsyah, who has a vast experience in power plant engineering, operational, and production, and currently serves as Vice President of Indonesia State Electricity Company, Power Plant Asset Management. He is also, professional in qualified risk management, Indonesia Engineering Professional, and Loop Certified Professional Coach. He graduated from Mechanical Engineering of Diponegoro University and holds a postgraduate degree in management from Sriwijaya University. Pak Dinda Alamsyah, silakan Pak.
Terima kasih, Bu Fatom. Izin share screen. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, salam sejahtera bagi kita semua. Good afternoon, ladies and gentlemen. First of all, I want to say thank you for this opportunity. I am Dinda Alamsyah, speaking in here on behalf of Pak Bambang Iswanto as Executive Vice President, Power Generation and Renewable Energy of PLN Sumatera and Kalimantan Business Regional. He's apologizing for not being here today with us due to attending another very important activity. PLN as electricity on state government company is ready to support the IKN PLN Group, which is consists of 13 subsidiaries companies, has total 64.75 installed capacity power generation plant. By end of 2021, PLN electricity energy source was 257 terawatt hour to serve 82.5 million customers. By end of 2021, 98.93% electrification ratio and keep on going was another PLN contribution to provide equality electricity access in Indonesia. Based on energy resources, PLN power generation profile be like this. Coal dominated the electricity supply, followed by combined cycle, and then diesel and gas engine. They are all grouped as fossil fuel power generation. As we have seen here, renewable energy already took a place. Hydro, and then geothermal, mini hydro, biomass, wind turbine, solar, and micro hydro. This is highlighted PLN Greens. Commitment for renewable energy transition as clearly stated in Transformasi PLN program. We have 4 pillars of transformation consists of green, lean, innovative, and customer focus. How about Kalimantan? Currently, electricity in grid system in Kalimantan are interconnection subsystem cover South Kalimantan, Central Kalimantan, East Kalimantan, and North Kalimantan. The second one is Katulistiwa subsystem covers West Kalimantan and interconnected to Sarawak grid system. All grid subsystem has enough reserve margin to accommodate electricity demand growth in the near future. The new capital city as a representation of national identity and as a smart, green, beautiful, and sustainable concept. Electricity concept for the IKN is smart, green, and beautiful. Currently, Kalimantan electricity grid system, Kalimantan interconnection, and Katulistiwa subsystem will be integrated as one big loop grid system. Energy flow from Eastern, Central, Western Kalimantan will be more dynamic and balanced. PLN ensuring the availability of reliable, efficient, clean, and environmentally friendly electrical energy. PLN Strategic Initiative for Electricity, IKN, based on RUPTL 2021 to 2030, estimated electricity demand at IKN approximately 900 megavolt ampere. It will be operated in stages by PLN. Plan design and criteria electricity in the new IKN based on RUPTL. Several concepts are implemented: zero downtime, circular configuration grid, and smart grid under ground cable, and green energy. National pellets is the first priority, 1 second downtime per year, and then government central office, 5.3 minutes downtime per year, and IKN, 53 minutes downtime per year. This is criteria of SMART. SMART is zero downtime, distribution automation system, smart grid, smart meter, and then green is renewable energy, less emission, electrical vehicle charging station, and then beautiful, underground cable, and futuristic design substation. PLN keep focus on electricity infrastructure project to improve electricity system reliability at IKN, adopted from RUPTL 2021 to 2023. We can sum up. The infrastructure improvement will be in the first, increasing total power generation in Kalimantan up to 2.8 gigawatt, and then increasing electricity supply from renewable energy up to 19%, less equal with gas 18%, and slowly ended the diesel only 0.4%. Transmission line reach out 11,000 kilometer circuit, substation 6,310 megavolt ampere. All mentioned above rely on forecasted electricity demand growth around 7.4%. This plan strengthens the PLN commitment to cope the electricity demand growth, which impacted by IKN. The more important thing is PLN ensuring the reliable and green electricity supply to be aligned with IKN vision. This picture shows us the forecast peak load electricity demand growth around 7.74%. PLN provides 34%. It's equal to 1,000 megawatt reserve margin. In terms of reliable electricity supply, 34% reserve margin is more than enough. The most interesting is additional power plant that dominated by hydropower generation plant with total of 1,053 megawatt. This is one of breakthrough, as we know that hydropower potential less utilized in Kalimantan. PLTA Mnur is the only one hydropower plant existed. The power plant ownership composition between PLN and IPP will be 72% and 28%. PLN is committed to support the new capital city, as we know as IKN, by providing the reliable electricity supply and environmentally friendly by improve the composition of green energy. This is end of our sharing. Thank you for your attention. IKN is Indonesian pride, and PLN warmly open to collaboration opportunity in the future to ensure the reliable electricity supply and greener for IKN, the new capital city of Indonesia. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Dinda. Ini questions start pouring in. I need to remind everyone to state who is the question addressed to which speaker. Untuk pertanyaan-pertanyaan mohon dicantumkan kepada siapa pertanyaan tersebut ditujukan. Terima kasih. Thank you, Pak Dinda. I'm sure there are a lot of questions for you waiting. So next we're gonna have our next speaker, Mr. Mohiuddin Sheikh from Qatar Coal. Mr. Mohiuddin is Qatar Coal Technical Manager. He is pivotal in the development of Qatar Coal's new cooling plants and the improvement of existing plants. He got a bachelor's degree in mechanical engineering from Gulbarga University and a master's degree in building services engineering from Heriot-Watt University. He also had many years with leading consultant and engineering firms in UK and Middle East, working on various large projects, stadiums, hotels, hospitals, malls, and managing their heating and cooling system. Mr. Mohiuddin, the floor is yours. I hope I pronounce your name correctly.
Yes, Assalamu alaikum. Thank you for the opportunity it's provided to us to present ourselves in this webinar. I would like to share the screen. If I may. Is my screen clear to everyone? I'm not sure if.
Yeah, crystal clear.
Yeah. Okay. Thank you. Thank you. As for the introduction, yes, I'm working as a technical manager in Qatar Coal District Cooling Company. We are one of the largest district cooling providers in the world. Yeah, and we are based in Qatar, and geographically here we are. Qatar Coal was established in 2003. And we have around 5 district cooling plants located within Qatar. We operate in 2 districts, mainly the West Bay and the Pearl, as we can see on the screen. So the first plant was built in 2006, the capacity of which is 25,000 TR, which also includes 25,000 ton-hours capacity of a test tank, thermal energy storage tank. The plant has 10 chillers, each of which is train is around 5,000 TR. There are 3 plants located in the West Bay network. The second plant is was commissioned in 2009 with 32,500 TR capacity and 20,000 ton hours of test tank. It has 13 chillers of similar capacity. Our P3, the plant 3 is the latest plant which was commissioned in 2018, which is operational with 35,000 TR capacity. All these plants are connected to a single network, which is in the West Bay. The 4th plant is IDCP, Integrated District Cooling Plant. At the time when it was built in 2010, it was the largest district cooling plant in the world. And if you consider currently, if you assess it based on its capacity and the network it is serving, it's probably still the largest cooling plant and network combined. It has 52 chillers, each of 2,500 tons capacity, arranged in series counterflow arrangement. The latest plant which is under construction, which will be probably operational in a month or 2, which is Jivan Island District Cooling Plant, which serves a new island called Jivan Island with a capacity of 18,000 TR and thermal energy storage tank of 15,000 ton hours. Atharcool provides end-to-end solution right from feasibility study to system design, construction, supervision of the project. We do operate and maintain. We enter into cooling agreements with the end users. We manage that process until billing and collection. So you can see, so right from the concept to the life cycle of the project, operations, billing and collection, so on and so forth. We provide full range of services. As this webinar is based on district cooling service in the context of the new capital city of Indonesia, I thought of sharing some of the key considerations that should be taken into consideration during the various phases of design, construction, and operation from my previous experience and the combined experience of Atharcool. The location of the plant, it's one of the key aspects in terms of firstly the weather, that is the weather conditions have to be considered while designing the plant, especially if you are most of the district cooling plants are water cooled, so wet bulb conditions play a critical role. So if you are in a dry if the weather is dry, it has got different challenges against where the weather has higher wet bulb conditions. So Indonesia being an island nation and most of the developments would be on the seashore, so it would experience higher wet bulb conditions. So cooling tower sizing and especially the cooling tower sizing would get affected with that. The second aspect would be the noise, because we have our plants located within the developed areas, and some of the sensitive buildings are very close to our plants. So the design has to take care of this, provide appropriate attenuation on the inlet and outlet of the plant and the plant facade itself. Aesthetics, as you might have seen, are the last plant which is under construction. It's almost fully covered in greenery because of its proximity and adjacency to some highly sensitive buildings. So that's another key aspect the location, geographical location within the development is also a key aspect, because if the plant is located in one of the corners, that would affect the pumping energy and the cost of pumping. In the long term, the operation cost would be really high. So ideally, it should be located probably in a central location to minimize the energy consumption. The second aspects I would like to highlight is the redundancy. So on the electrical side, N-1 at least should be considered on the incomers. Mechanically, yes, standby arrangements on chillers and pumps, although this has to be weighed against the cost as well, because the capital cost would be high. So depending on the criticality of the plant and the loads it is serving, decisions have to be made on the redundancy aspects. Future provisions, not all developments get built or the city is built at once. So as per the master plan, all the future provisions in terms of expanding the network, expanding the cooling capacity, appropriately have to be provided. The other aspect is the thermal energy storage systems. It is vital to have thermal energy storage systems on for that matter, any district cooling plants, especially when you are in the ranges of around 10,000 TR, it would make more economical sense. The energy storage could be water or ice. Water turns out to be a cheaper and most cost-effective option. Most of our plants have thermal energy storage, barring IDCP. It would help in shaving off the peak loads. And also, if you look at it from another point of view, if your plant is provided with renewable energy source, obviously the source will not be able to serve the whole of the plant because of its higher energy requirement. But you can maximize the use of renewable energy when the thermal energy storage system shaves off your peak. Concurrently maintainable, because the DCPs, district cooling plants, are critical infrastructure, and any interruption for either accidental or for maintenance, any reduction in the capacity during the peak conditions would severely affect the service to the end users. So the systems have to be designed so that even summer you are able to maintain in your critical plant. Piping and distribution network and valve chambers. So the PDN has to be design taking into consideration, especially if you are in the coastal area, water table. I am assuming the water table would be high, as Qatar is an island nation, same as Indonesia. So the water table is high in the areas where we serve. So that poses a challenge to us, having properly designed piping system to take care of corrosion because of the seawater. That is critical. And the sizing of the distribution network has to take into consideration the capital cost against the operation cost, and the future expansion, corrosion, etc. Energy transfer stations would be required in each and every building to serve the load. The location of it would be critical to have proper interface and accessibility for maintenance in the future within the buildings. Valve chambers, I did cover with the PDN. The same kind of challenges would apply to the valve chambers. Low delta T, special attention should be given to inherently all the DCPs at some point of time would encounter the low delta T syndrome, which is the customers would not be able to return the water at the design temperature. So if the return water temperature is lower than the design, that would impact your pumping volumes. You will have to pump more water, spend more energy on pumping, and add additional chillers to meet the temperatures. So that would significantly scale up the operational cost. Also, if this happens during the peak summer season, your additional capacity would be required. That means if you have designed a plant for 30,000 TR, you might not be able to take 30,000 TR out of that plant at all. It would be significantly less depending on what the temperature of water would be, the return water temperature. So during the design stage itself, adequate provisions have to be built in, although the problem originates from the customer side, but there are measures which could be taken while designing the PDN as well as the plant to mitigate to a certain extent so that your customer service would not be compromised. Although in all the cases, there would be additional cost of operation, but the serving of the customer is also important. Building HVAC systems, again, care has to be taken as to educate or have proper guidelines for the customers when they design the buildings, to have all their equipment which are suitable for district cooling operation, especially in terms of temperatures and pressure drops. And all the control valve sizing, coil sizing should be done properly to avoid any load related issues in the future. Control valves preferably should be PICVs, not on-off or two-port modulating valves. So these are the key considerations during the design stage. During the construction stage, I'll highlight only a few. There would be many things. We are still constructing our 5th district cooling plant, which is for the Jivan Island. The most important thing which we did know and took care of is procurement. Considering that we have been constructing this plant during the pandemic, during the COVID pandemic, procurement was the key. So, and going forward, it will be the case if the construction is going on now, especially with the current situation with Ukraine and any other issues, shipping issues. In the current scenario, procurement has to be planned very accurately, and enough cushion has to be built into the lead times to avoid any delays. Utility coordination is one of the key because the DCPs require significant power and other utility connections. So those have to be planned well in advance, and even for the chill water network, coordination with on the chill water corridors is also a key aspect. Access and maintainability. Although the plants are generally designed nowadays using the BIM and 3D modeling, but still care has to be taken in terms of accessing each and every maintainable part of the plant. At times during the construction phase, not enough attention is given to this aspect, and which could lead to significant issues while maintaining the plant. Especially considering that this plant serves hundreds of buildings. Any issue here would severely affect a large number of customers. Testing and commissioning, making sure that the plant delivers whatever it has been designed to is also a critical aspect. Having the full load plant testing during the summer is important, especially testing of the cooling towers during the high wet bulb conditions. Of course, health and safety should be the first among all these, last but not least, should be the top priority, as not only during construction but during operations, as DCP have the scale of the plant is big and the risks are high. During the operational phases, reliability and integrity is the key. The KPIs. Qatarcool has focuses a lot on reliability aspects. Care should be taken, even during the design stages to have a standby arrangement. If not, Qatarcool follows condition-based monitoring strategy. Our plants have online vibration monitoring of all the critical plant items like the chillers, the pumps, the cooling tower motors, to catch any issues well in advance before it fails. Maintenance of plant and chiller operations is critical, as these are the chiller is the heart of our operation. So as the pumps and the cooling towers. Managing low delta T, as you can see, this issue, it is a very significant issue because it can affect your customers, your customer service, your bottom line, your profit significantly. So the care has to be taken in all the phases, during the design, during the construction, during the operation as well. So we do have these issues in our network, but we do mitigate with various measures within our plant and PDN network. Fouling and corrosion and chemical treatment. One of the very key aspects of operating a district cooling plant. Fouling could significantly affect your plant efficiency. So the chemical treatment, the water treatment plays a very crucial role. They should not be ignored. Any slippage in the chemical treatment program for your water treatment could affect the integrity of the PDN, your plant, and affect your efficiencies very significantly. Water management, as Qatar is in the Middle East, and water is a very precious resource. I would say not even in this climate, but everywhere in the world. So water management is the key. Qatarcool in its plants, in IDCP we have seawater RO. We use seawater for DCP. In other places we use direct treated sewage effluent, TSC, and in one of the other plant it's TSC with RO. So we utilize recycled water and seawater only. Qatarcool hello. Hello, can you hear me? There seems to be a...
We can hear you.
Okay. All the plants have to operate efficiently for obviously the key reasons are to minimize the energy usage and to as a DCP to minimize your costs and increase your profits. So Qatarcool is currently working on optimizing solutions. Especially, we have been recently we have developed a solution jointly with a European AI firm, and we jointly own the IP for that to optimize the ETS to maximize the return water temperature. So as compared to a normal control solution, the one which was developed and implemented and tested gave us on an average 1 degree higher return temperature, which is significant for us in terms of efficiency and capacity. So we are in the process of developing our own plant optimization software based on AI in collaboration with the same firm, which we will jointly own. So we are on that path, and we are actively working on that, which would reduce our energy consumption and significantly increase our bottom line. These were the key aspects which I would like to highlight during the design, construction, and operational phases. As I said, Qatarcool is district cooling, one of the largest district cooling providers in the world, which can provide end-to-end solutions right from concept to building the DCPs, operating throughout the lifetime of life cycle of the DCP, including billing and collection and so on and so forth. So should you and we would be very much interested in for any opportunity which is available for us to invest, build and operate the plants. We would be more than welcome to explore any opportunity. Here is my contact details. I can be contacted, is my email address or through the organizers. Any questions as per the procedure of the webinar? I'm here available to answer the questions anytime. Thank you very much.
Thank you, Mr. Sheikh. It is great to have you here sharing your experience in DCP. Because time is limited, we need to move on straight to our next speaker. Pak Rana Yusuf Nasir. Pak Rana is our expert in energy efficiency and heating, ventilation, and air conditioning. He graduated from ITB, majoring in building physics engineering. He is the founder of PT Arkon Pratama, Green Building Council Indonesia, Board of Experts in MASKE, and also Board of Governance ASHRAE Indonesia chapter. Worth noted as well that he received 2 awards for his active role in Environment Program and Ozone Award from the Minister of Environment in 1998 and 2008. Pak Rana, the floor is yours, Pak. Rana, are we losing you?
Mute that. Okay. 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 Thank you for your introduction, Ibu Fatom. Distinguished ladies and gentlemen, good afternoon. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, Om Swastiastu, Namo Buddhaya, salam kebajikan. To be honest, it is an honor for me to have the opportunity to be invited in this webinar. And I think I would like to share some of my experience in the HVAC system. But let I tell you my problem. As a matter of fact, I just been informed yesterday and just realized that this webinar will be held and using an English language. The problem is last August on an international webinar talking also about the webinar, about the district cooling, the participant coming from USA, Thailand, Malaysia, Singapore, Japan, and as a speaker delivered my presentation, of course, in English language. So for this webinar, because I assume this is in Indonesia, when I was preparing my presentation material, what I have done was I translate some slides from my original last year previous English to Indonesian language. So right now, what I have is my presentation in Indonesian language. So please allow me also that I will deliver my presentation using the Indonesian language. I have the confidence that mostly the participants are the Indonesians. And so please apologize me, especially for Peter and all other participants from the overseas, that I will use Indonesian language in delivering this presentation. I would like to share my presentation. Okay. Wow, wow. Where's my presentation? Is it? Okay. Yep. Oke, izinkan saya Bu Fatom menyampaikannya dalam bahasa Indonesia karena saya punya presentation material udah disiapkan dalam bahasa Indonesia. Jadi topik yang ingin saya bawakan adalah tentang district cooling system di ibu kota negara di Kalimantan Timur, tentang konsep, challenge, dan benefit-nya. Karena kebetulan saya juga menjadi bagian daripada narasumber dari tim PU untuk perencanaan baik Istana Kepresidenan maupun juga untuk kawasan hunian, rumah susun dan sebagainya di IKN. Baik, saya teruskan. Ini ibu kota negara Nusantara, tadi sudah kita lihat videonya, ya, ini kompleks yang sangat cantik. Visi dan misi dari IKN Nusantara ini adalah satu green, kemudian smart, ya, green, smart, sama forest city. Dan ini semua menandakan bahwa direction atau objektif dari IKN adalah menuju kepada sustainability sesuai dengan target NDC kita, National Determined Contribution untuk pengurangan gas rumah kaca. Kita semua udah tahu itu. Baik, kita teruskan. Kita bandingkan individual dengan dengan district cooling, individual system. Cooling system misalnya ada satu kawasan ada 6 gedung A sampai F, ya, masing-masing punya chiller plan sendiri, ya, ini chiller plan dalam warna kuning. Tetapi kalau district cooling kompleks yang sama 6 itu katakanlah yang gedung A itu masih tetap individual cooling, tetapi B, C, D, E, F itu di dalam district cooling karena itu yang tetap masih individual. Chiller plan-nya dikasih warna kuning, sementara yang lainnya sekarang dalam warna putih, menandakan ini adalah untuk air side-nya, jadi air handling unit. Baik, mari kita teruskan. Bagaimana kita memahami kelebihan atau benefit daripada district cooling? Ini salah satu yang bisa kami sampaikan. Pertama yang harus dilakukan adalah kita harus melakukan analisa simulasi dari cooling load profile pada hourly basis, jam per jam. Katakan tadi ada 5 gedung A, B, C, D, E misalnya, jam ke jam ini misalnya teman saya kasih lebih sedikit interval 3 jam, tapi sebetulnya ada jam per jam dan ini adalah cooling load profile-nya, di mana untuk gedung A itu peak load-nya, beban maksimumnya terjadi pada jam 12 900 ton, pada gedung B 1200 dan sebagainya, sehingga peak load dari seluruh gedung-gedung ini untuk A sampai E adalah 6.300 ton. Dengan masing-masing chiller, kalau memang individual, yang untuk gedung A 2 kali unit dan di total ada 14 set chiller. Sementara untuk district cooling ini sebetulnya adalah kombinasi, ya, komposit daripada seluruh cooling load profile yang kalau kita lihat di sini pada rows yang paling bawah, dan puncaknya daripada total district cooling itu adalah 5.250 ton. Sehingga peak load instantaneous dari kawasan yang menjadi beban dari district cooling adalah 5.250 ton atau kira-kira 83% dari kalau masing-masing individual cooling. Jadi ini lebih rendah kira-kira 16,7%. Nah, district cooling dari beberapa kasus itu bahkan bisa mencapai 20% atau lebih rendah, ya. Ini tergantung tentu dari tipe gedung yang ada di dalam district cooling, karena itu akan mempengaruhi terhadap cooling load profile sama operating hour daripada setiap gedung. Ada yang 10 jam, ada yang 24 jam dan sebagainya, dan penting sekali untuk membuat analisa semacam ini yang biasanya didapat dengan melakukan simulasi daripada energy modeling system yang menghitung cooling load. Baik, mari kita teruskan. Jadi kalau ini saya pindahkan gedung A, B, C, D tadi, itu peak load-nya ya, tadi total 6.300 ton, dan masing-masing ini, misalnya yang 900 ton, ini disuplai oleh 2 kali 450 dan seterusnya, sehingga dibutuhkan 14 set chiller untuk individual system. Kemudian untuk water pump-nya, 2 chiller, ini dipasang 3 pompa, karena 1 dianggap standby. Chillernya saya masih belum hitung standby, nanti bisa dianalisa. Condenser pump juga 1 standby, cooling tower tidak ada standby, maka total equipment-nya adalah seperti yang ditunjukkan pada kolom paling kanan. Sehingga kita bisa lihat bahwa total peralatan yang ada untuk individual system itu ada 54 unit peralatan, terdiri dari 14 set chiller, 19 set water pump, 19 set condenser water pump, dan 14 cooling tower. Sementara kalau menggunakan district cooling, kita hanya membutuhkan 14 unit peralatan. Terdiri dari 3 chiller, 4 unit pompa, 4 lagi condenser pump, dan 3 cooling tower. Nah, kalau kita anggap bahwa chiller ini juga harus ada standby, saya sudah ngitung, maka jumlah dari individual itu tambah lagi semuanya, itu 5, jadi 59 dibandingkan ini 15. Jadi artinya apa? Jumlah peralatan individual cooling itu 54 buah peralatan, sementara district cooling adalah hanya 14, artinya hanya 26%. Jumlah peralatan yang lebih sedikit, tentu biaya investasi lebih rendah. Kenapa? Nanti ada slide berikutnya tentang biaya per dolar, biaya per ton capacity. Yang paling penting adalah lingkup pekerjaan maintenance-nya menjadi lebih rendah. Nanti dibahas pada slide yang lain. Pertanyaannya kemudian, district cooling system itu bagusnya di mana? Where it is the most beneficiary for the district cooling to be employed? Di sini ada beberapa, yaitu pertama kompleks gedung pemerintah seperti di Putrajaya di Malaysia, universitas dan college ya, ada beberapa yang sudah ada rumah sakit seperti Texas Medical Center, di airport kita sudah melakukan di International Airport Ngurah Rai di Bali, ada kompleks militer dan sebagainya. Jadi ini tepat untuk kawasan sebetulnya yang dalam satu manajemen seperti kompleks pemerintahan, hospital, university. Bagaimana kalau dalam sebuah kompleks yang commercial area, seperti misalnya SCBD mau dipasang district cooling, itu bagaimana? Karena kan gedungnya macam-macam, yang punya macam-macam, operatingnya juga oleh macam-macam, sehingga ini harus ada sebuah regulasi, ada intervensi daripada pemerintah, adanya regulasi yang mengharuskan kawasan tertentu misalnya ya harus menggunakan district cooling dan melarang tiap gedung di dalam kawasan tersebut mempunyai chiller plant sendiri. Contohnya di Dubai, mungkin di UAE atau mungkin di Qatar tadi Mr. Sheikh juga memberikan contohnya misalnya. Itulah sebabnya di UAE itu district cooling sangat maju luar biasa karena pemerintah menerbitkan regulasi. Baik, ini adalah kompleks Istana Presiden di IKN di Kalimantan Timur. Jadi ada banyak gedung-gedung mulai dari Istana Negara dan sebagainya, dan yang di service dilayani oleh district cooling itu ada 10 gedung. Jadi gedung B, Istana Negara, kantor Presiden C, kemudian ada pavilion Presiden dan sebagainya dan seterusnya. Memang ada misalnya gedung genset juga di sini. Kenapa? Karena gedung genset ada ruang server dan ada ruang office-nya. Kemudian ada gedung damkar ya, yang M ini juga ada office-nya. Jadi ada 10 gedung yang dilayani oleh satu district cooling system yang letaknya itu adalah di gedung bangunan pendukung di sini. Fasilitas pendukung. Jadi chiller plant district cooling sudah direncanakan di sini. Sebagai informasi, ini kira-kira sudah hampir positif, definitely bahwa kompleks Istana Kepresidenan di IKN itu akan menerapkan, mengimplementasikan sistem district cooling. Baik, mari kita teruskan. Apa keuntungan district cooling dari energi efisiensi misalnya? Penghematan energi ini karena apa? Karena chiller dengan kapasitas lebih besar, lebih efisien. Kalau tadi ada 14 chiller pada 5 gedung tadi tabel contoh saya, rata-rata 400-500 ton, tapi kalau dalam district cooling itu dengan menggunakan 2.000 ton satu unit misalnya. Nah, ini kelihatan dalam grafik di sini ya, makin ke kanan ini kapasitinya makin besar, ya, makin besar chillernya, dan yang sumbu vertikal ini adalah efisiensi kilowatt per ton. Makin besar kapasitinya, makin rendah kilowatt per tonnya. Jadi kalau dengan demikian maka kita bisa mengatakan bahwa kilowatt per ton untuk district cooling itu jauh lebih hemat dibandingkan dengan individual cooling. Baik. Kemudian pembebanan biaya ke klien itu dihitung dari jumlah pendinginan yang dipakai, yaitu dengan melakukan pengukuran pada chill water flow yang mengalir ke setiap gedung. Jadi harus ada flow meter, dasar itulah yang dipakai untuk pembebanan biayanya. Baik, kita teruskan. Apalagi yang lain menghemat ruangan atau space. Kenapa? Karena chiller plan itu jadi satu. Seperti tadi di kompleks istana, chiller cooling plant terletak di bangunan pendukung. Jadi di setiap gedung itu tidak ada lagi chiller plant, yang ada hanya ruang AHU, sehingga space-nya menjadi lebih hemat. Baik, mari kita teruskan keuntungan district cooling lain dari sisi maintenance. Tadi sudah dibahas jumlah peralatan equipment yang lebih sedikit. Itu artinya apa? Kalau jumlah lebih sedikit peralatan, maka moving parts-nya juga menjadi lebih sedikit. Kalau moving parts lebih sedikit, kemungkinan terjadinya kerusakan tentu lebih kecil dan pekerjaan repair akan banyak berkurang. Pemeliharaan lebih mudah, lebih sederhana, dan sistemnya lebih reliable. Yang lainnya kemudian semua peralatan chiller plant menjadi satu di chiller cooling plant. Jadi maintenance dan operasional akan menjadi mudah karena dioperate dari satu tempat, ya. Dan juga pemeliharaan untuk chiller plan-nya saja, tapi tidak termasuk AHU. Jadi pengelolaan akan lebih ekonomis dan mudah. Ada satu tim operator di sentral. Dan pengelola gedung dengan sendirinya itu nggak perlu lagi pusing untuk memikirkan operation sama maintenance dari chiller cooling plant. Pengelola gedung bisa fokus pada bisnis mereka sendiri dan tidak perlu memikirkan pengoperasian dan pemeliharaan sistem pendinginnya. Baik. Ini biaya investasi. Jadi tadi misalnya untuk individual system, ya, untuk gedung yang 5 tadi, di peak load-nya 6.300 ton, ada 14 set chiller, tadi sudah diinikan, ya. Jadi kira-kira 400-an ton satu chiller. Sementara kalau dibuat district cooling, totalnya 5.250 tadi sesuai dengan itu, maka ada 3 chiller cukup dengan capacity 1.750. Nah, kalau dilihat dari sini sudah lebih kecil kapasitasnya, jumlahnya juga lebih rendah. Jadi cooling capacity lebih rendah, jumlah peralatan lebih sedikit. Artinya ini biaya investasi lebih rendah. Karena tadi sudah dikatakan bahwa makin besar kapasitas chiller, lebih efisien dia. Nah, sekarang kalau dilihat dari soal harga investment, harga chiller per unit dengan kapasitas yang lebih besar, harganya lebih rendah dalam US dollar per ton. Ini terlihat dari grafik ini. Grafik ini bersama-sama dengan grafik tadi mengenai kilowatt per ton efisiensi. Saya minta dari 2 brand chiller yang leading. Dari 4 big guys, ya, kita tahu the 4 big guys, brand dari chiller, saya minta 2. Saya nggak bisa sebut namanya tentunya. Jadi dari 2 ini kelihatan tadi bahwa kilowatt per ton menjadi lebih rendah pada kapasitas lebih besar. Kalau ini adalah biaya investasi. Makin besar kapasitasnya, maka US dollar per tonnya makin rendah, dinyatakan dalam price ratio, di mana dianggap bahwa chiller dengan 400 ton itu menjadi benchmarking, menjadi acuan. Sehingga misalnya untuk chiller yang 1.000 ton, kira-kira harganya itu 55% dalam harga per ton dibandingkan dengan unit yang lebih kecil yang 400 ton. Jadi kelihatan bahwa makin besar chillernya, makin rendah harganya per ton, artinya investasinya makin rendah. Baik, mari kita teruskan. Apalagi yang lain, yaitu laporan keuangan. Ini ada keuntungan. Kenapa? Karena tidak membebani balance sheet daripada klien, daripada gedung. Ini yang disukai oleh para pemilik gedung atau ya pada kompleks komersial karena tidak membebani balance sheet. Kenapa begitu? Pada individual cooling, kalau gedung tersebut menginvest untuk chiller plan-nya, maka harganya itu masuk di dalam neraca pada pos fixed asset. Fixed assetnya naik. Dan untuk membebaninya, fixed asset, dananya berasal bisa dari bank loan, naik juga karena ini kan harus balance, atau bisa juga dari dana sendiri, equity. Tetapi kalau di district cooling, itu nggak ada, karena fixed asset-nya tidak dilakukan oleh gedung tersebut, tetapi oleh developer daripada district cooling. Jadi tidak masuk di balance sheet, artinya tidak berubah. Jadi ini keuntungan dari sisi finance dalam hal balance sheet. Keuntungan district cooling dari sisi finance yang lain adalah simple payback period-nya lebih pendek. Ini kita bisa lakukan, sudah pernah dilakukan pada contoh di Bandara Ngurah Rai Bali Internasional, karena saya yang kebetulan terlibat di sana, district cooling itu payback period-nya sangat pendek karena di sana bahkan saving-nya itu bisa sampai hampir 29%. Kemudian kalau kita melakukan dengan life cycle cost analysis, ya LCCA, district cooling mempunyai IRR yang lebih baik. Karena life cycle, anggap saja gedung itu lifetime-nya 50 ton. Sementara lifetime daripada chiller plant itu umumnya 30 ton. Jadi dalam masa lifetime 50 tahun, itu paling tidak sudah ada 2 kali pembelian daripada chiller plant. Dan itu akan membuat harganya, investasinya menjadi naik. Hal yang lainnya adalah insurance. Premi insurance dengan district cooling menjadi lebih rendah. Kenapa? Oleh karena jumlah peralatan equipment yang lebih sedikit. Jadi yang harus di-cover oleh insurance company lebih sedikit. Juga kalau dilihat daripada sistem listrik, kabel, panel, kontaktor, dan hal-hal lain yang mempunyai risiko kebakaran lebih sedikit. Karena semuanya pada satu tempat di central chiller cooling plant, sehingga preminya bisa lebih rendah. Pada dampak lingkungan, ada tentu kita lihat ada penghematan energi sudah dibahas, dan ini adalah berarti mempunyai juga sumbangan terhadap pengurangan emisi CO2. Ya, satu. Yang kedua juga mempunyai dampak positif bagi keberlangsungan sustainability daripada energy supply kita, energy supply. Ya, karena ini artinya mendukung nasional, daya tahan nasional untuk energi. Yang lainnya dampak pada penanganan refrigerant. Tadi disampaikan tentang refrigerant yang menjadi masalah besar, betul. Di dalam district cooling, refrigerant yang ada hanya pada chiller cooling plant system saja. Jadi itu bisa diisolasi di dalam satu ruangan. Kalau setiap gedung individual cooling, di setiap gedung ada chiller plant, ada potensial untuk kebocoran refrigerant. Dan ini sangat penting, karena tadi kalau nggak salah Pak Peter yang mengatakan tentang refrigerant sangat penting, karena memang refrigerant itu justru dampak daripada global warming impact-nya, ya, walaupun itu tidak direct ya, bukan total direct untuk global warming impact, tetapi kalau refrigerant adalah indirect ya di dalam bidang air conditioning disebut. Tetapi ini mempunyai dampak terhadap lapisan ozon dan gas rumah kaca. Sementara refrigerant juga adalah zat yang berbahaya kalau mencapai sebuah konsentrasi di atas konsentrasi yang disebut AIL, Allowable Exposure Limit. Sehingga ini harus dimonitor, harus dikontrol. Lebih mudah kita mengontrol karena berada pada satu distrik chiller plant. Tidak ada chiller plant lagi di setiap gedung. Yang terakhir adalah mengurangi gangguan suara noise karena cuma ada satu chiller plant dengan suara untuk dari chiller, dari pompa dan sebagainya, dan tidak di dalam gedung. Di dalam gedung peralatan hanyalah air handling unit yang suaranya tidak begitu tinggi. Oke, tinggal 2 slide lagi. Pertama tentang thermal energy storage tadi sudah disampaikan baik oleh Peter ataupun oleh dari Qatar tadi. Karena ini sangat penting di dalam district cooling, kita harus menerapkan thermal energy storage, ya, menyimpan chilled water yang diproduksi pada saat biaya listrik rendah dan dipergunakan saat biaya listrik tinggi. Nah, sayangnya di Indonesia ini listrik yang tinggi itu biayanya justru pada malam hari. Kira-kira begitu. Sehingga banyak sekali thermal energy storage hampir-hampir tidak banyak bisa diaplikasikan karena sebetulnya di sini dengan adanya tingkat harga listrik yang rendah di malam hari itu tidak mendukung konsep thermal energy storage. Memang ada manfaatnya, yaitu pengurangan kapasitas terpasang, penghematan biaya operasi, menyeimbangkan profil beban thermal dan biaya energi. Ada dua macam TES ini, yang sensibel yaitu chilled water bersuhu rendah, dan yang latent dengan ice. Tadi dari Qatar Cool menganjurkan untuk pakai ice. Tapi kalau pakai ice, satu yang harus kita awasi adalah harus adanya isolasi pada tangki thermal storage-nya. Pada thermal ice storage-nya harus ada isolasi. Dan ini tentu tambahan biaya. Oke. Slide terakhir mengenai kesimpulan daripada district cooling system. Benefitnya apa? Atau advantage? Jumlah equipment, chiller, pompa, dan cooling tower lebih sedikit. Investment atau installation cost lebih rendah, tentunya tadi sudah dibahas. Konsumsi energi lebih hemat, tadi juga sudah dibahas. Dan ini tentu berkaitan dengan operating cost yang lebih rendah dan maintenance cost yang lebih rendah. Memaksimalkan, mengurangi space ruangan, dan untuk lingkungan ada emisi karbon, emisi udara, ya, dan noise-nya, karbon, dan seterusnya. Regulasi dibutuhkan untuk mendorong atau mempromosikan district cooling di kawasan yang bukan dalam satu manajemen atau satu institusi, terutama adalah dalam kawasan komersial. Saya kira saya cukupkan presentasi saya. Terima kasih banyak kepada seluruh partisipan di sini. Thank you very much. Saya kembalikan ke Ibu Fatom. Wassalamualaikum warahmatullahi wabarakatuh. Saya stop share ya Bu ya.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Rana. With that, we conclude the presentation from all our speakers, and we can now enter into question and answer session. We have here plenty of questions. I have to apologize. I don't think we can raise your questions during this session, but rest assured that your questions will be answered by individual speakers later on, and it will be organized by the organizers. Okay, can we have all the speakers' video to be on, and we can have a discussion session here? Pak Rana, Pak Dinda, Pak Mohyudin.
Yeah.
And also Mr. Peter Lundberg, because we do have a question for you too. Am I missing somebody here? Okay, so first question to Mr. Peter. Do we have Mr. Peter? Yeah. So question from Nur Aziza here. Hi, question to Mr. Peter Lundberg. From your perspective, what is the main challenge for developing district cooling system in Indonesia? Seems like there's not too many implementation of district cooling system in Indonesia yet. Furthermore, can the system pave the way to more sustainable energy implementation? Thank you. And I think this question, should be addressed to Mr. Peter and also Mr. Sheikh, from your experience too. Peter?
Yeah, thank you for the question. Well, I will start with the second one. I mean, looking into the potential, and I think we can come back to some of the slides that I showed in my speech earlier. Is that the cooling demand is growing very rapidly in Indonesia and the ASEAN region. At the same time, there's a large part of the population live in cities, and that the urbanization rate or trend is is continuing in Indonesia and other countries as well. It's a global trend, and with that, especially you coming into with the economic growth and the potential for that in Indonesia, I think putting all these issues combined, I think it's very important to choose the most efficient ways of cooling, right? And in cities where you have concentrated energy demand, also mixed-use buildings, including residential buildings, commercial buildings, but also hospitals, shopping centers. If you combine, that's a perfect spot for centralized cooling system or district cooling system to really maximize energy efficiency. But also, as mentioned, is also another way to introduce more renewable energy, as you can produce chilled water when you have access to renewable energy. So it plays a vital role, definitely. And I think there's a huge potential in Indonesia, and especially as we talk about the new capital city. Of course, it's much easier to build district cooling system if you start with building a new district or a new, in this case, a new city, because then you really can plan the system to be optimized. Similar to how you're planning the power grids or water utilities, wastewater utilities. I think thermal energy can be considered as a kind of utility as well. And I think the expertise from Qatar Cool could be very interesting to utilize when building this new capital city, because Middle East, of course, experience a lot of experience in district cooling. Challenges. Well, I think this is not in Indonesia. There are general challenges in different parts of the world, but looking into Asia, I think one challenge is that I think also that Qatar Cool presented this very well. It's very important to look into all the aspects of a district cooling city: the design, the construction, the operation, and maintenance, because there's always risk of having a failed system, a failed project, or a project where it doesn't really work as planned and so forth. And then it becomes, like a brand that district cooling does not work, right? So I think that's a big risk, that you really need to follow through on all these phases in a district cooling project. Otherwise, there's a risk that, further project developments, investment will be, look for other solutions. So, okay, thank you. Thank you.
Thank you, Mr. Peter. For Mr. Sheikh, if you have any additional comment, your experience.
I think Peter covered it very well. But what I would like to add is, for a district cooling system to be implemented, all said and done regarding renewables and energy conservation targets, and that's all fine. It has to make a commercial sense. Unless it makes a commercial sense, there will be no uptake for this. There will be so much resistance from the end users. So that's one important thing. For that to happen, the developers have to buy into that from day one, and the tariffs have to be set accordingly. That's another aspect. As Peter said, it's quite easy to implement a district cooling system in a new development, in a new area, in a new city where the energy is concentrated. The more spread it is, it will not be viable, because your design is fine, construction is fine, your operational cost would be very significant because of your additional pumping energy and maintaining of a very vast network. And also if you want to implement, even if you find that in existing areas and cities where you have a concentrated load, it is very challenging, difficult to implement a district cooling system, because every building would have been designed to slightly different temperatures. The equipment selection would have been different. So even in Qatar, like the districts where we serve in, say for instance in West Bay, we serve 70% of the West Bay district. When the clients come back to us who have used conventional cooling because they want to transfer to district cooling, it involves a lot of cost because firstly, in some of the buildings, the chillers are located on the top of the building and your piping is like the opposite way around, whereas the ETSs would be on the ground floor. The second thing is the temperatures would be different. So these are some of the challenges for implementing the district cooling system in existing areas.
Okay, thank you, Mr. Sheikh, for your insight. We are very limited with time now. So we're just gonna pick a few questions for Pak Nanang. Do we still have Pak Nanang here? Do we still have Pak Nanang with us? No. Okay, so next question is for Pak Dinda Alamsyah. Pak Dinda, you're still muted, Pak. Pak Dinda, the question is from Ainul Hakim. Currently, does the transmission line at the location of the prospective IKN already use the 500 kV system? If not, when will the change to 500 kV transmission system be made? Because in my opinion, the only reliable transmission system currently is 500 kV transmission system. Moreover, this will be an underground line, not an overhead line. Have you started a study on this, and what will be the target for the transmission system at IKN Kalimantan P?
Okay, thank you for the question from Ms. Ainul Hakim.
Yes.
I think based on RUPTL, transmission line still use 150 kilovolt and line underground. I think that's all.
So when is the transition be ready, Pak? Dinda, what will be the target for the transmission system?
I think still on progress planning and progress on division planning of PLN.
Okay. Sorry, I'm having trouble going through the question here. Hang on a second. Okay, one question, and I'm afraid this will be the last question for Pak Rana. Where's the power needed for the district cooling coming from? Can it be from cogeneration using waste heat from gas turbine? Gas is indeed energy, fossil energy, but the carbon emission is relatively low. How do you see this, Pak Rana? Pak Rana, you're still on mute.
Oh my goodness, sorry. Okay. Thank you for the question, Pak Anton. I think your question is asking, what is the energy source using for the district cooling, and how if we use the cogen as the energy source? There is some application on the district cooling, but of course not in Indonesia, related with the cogen that, for instance, a very big area using the district cooling system, and this big area like a part of a city, and of course they produce a lot of waste. So then, because the volume of waste is so big, and then there's an institution who will process the waste to heat, then we can get a heat from the waste. This is also some of the form of the cogen. So then if we have the heat, then we can use the heat for the absorption chiller system. And this is very, very efficient, because as you know that the absorption chillers, the COP, the efficiency is even double, much better than the electrical chillers for that. So thank you for that. That is my question, Ibu Fatom. Thank you. Hello, Bu Fatom.
Sorry, I was on mute.
Okay.
Okay. So thank you, Pak Rana, for the answer. And so, ladies and gentlemen,
excuse me, Bu Fatom. There is one question to me, and it is very interesting asking, because my presentation slide is showing that for the chillers unit, there is no standby at all. But this is just only as a sample of the calculation. If you do remember that there is 14 chillers compared with only 3 chillers, and then there is no standby chillers. Of course, this is the answers to the participant who raised this question. Of course, we have to have the standby chillers. The standby chillers, and then the next question, what is the capacity for the standby chillers? Of course, the standby chillers, it is much better to have a standby with the same capacity with the big chillers, but also in, not only having the standby chillers with the same capacity, but I also recommend that we have to have a baby chillers to cover on the night load, because the night load is lower. So thank you for this opportunity, Ibu Fatom. I'm sorry. Thank you.
Thank you, Pak Rana. Okay, so again, must apologize for the restriction on time here. Unfortunately, we have to finish this session. I see this has been a great discussion, and I hope it gives us, all of us, well, certainly it gave me insight, deeper knowledge regarding the process, benefit, and challenges of DCS, district cooling system, especially on its implementation on the newly planned capital city. Moreover, I hope this will continue inspire each one of us to promote energy efficiency, giving positive impact for the better world and future. All your questions will be answered and will be responded to you. And I would like to thank all the speakers and guests of honors for their contribution in shaping this country energy roadmap, and also for their valuable time to share it with all of us. Thanks to all attendees for their participation and stimulating questions. And of course, last but not least, thanks to the organizers, PJCI, APUEA, Rugged Monitoring, Pamerindo. We'll hope to see more of this in the future. With that, I give the floor back to Anissa, our MC. Thank you.
Thank you, Bu Fatom, to lead the webinar and all the speakers. We appreciate your time and expertise on today's topic. Thank you to our sponsors, Rugged Monitoring. For more information about Rugged Monitoring, please contact info@ruggedmonitoring.com or visit www.ruggedmonitoring.com or LinkedIn www.linkedin.com/company/ruggedmon. Ladies and gentlemen, thank you for watching. For recorded session and previous energy talk, please visit and subscribe our YouTube channel, Indo Indonesia, part of Informa Markets. And then visit Electric and Power Indonesia 2022. Electric and Power Indonesia will be back this year in a hybrid format from 14 until 17 September 2022 at the Jakarta International Expo Kemayoran, where we will combine a physical exhibition with various activities that will be carried out through a digital platform. Electric and Power Indonesia 2022 will be the perfect hybrid platform to do business with prospective clients who are actively looking for suppliers or buyers, as well as seeking the latest information in the energy sector. Thank you for being part of Energy Talk 13, a collaboration between Electric and Power Indonesia, Indonesia's Market Initiative, and Asia Pacific Urban Energy Association. See you in the next webinar. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Peter, Pak Dinda, Mr. Syaikh, Bu Fatom, Pak Rana, atas for your support for this Energy Talk series.